Everybody. I am Jeannie Rogers with Secure Ideas. I am here to introduce our free webinar of today. Secure Ideas is a cybersecurity company that does a lot of pen testing for a lot of companies all over the world, and we absolutely love the fact that we can provide training, and especially free training, to everyone as much as possible. The person speaking today is Corey Sable. He is one of our awesome consultants at Secure Ideas, and he is super into game development. So he wanted to do a talk about it, and I will let him take it away.
Okay, yeah. So as Jeannie said, my name's Corey Sable. I'm a security consultant at Secure Ideas, and what that means is I basically get paid to hack stuff and then tell our clients, you know, how to fix that, right? Ways that they can remediate that. And I also get the chance to explore interesting avenues of security. And so the chance I was afforded sort of recently, thankfully, is the opportunity to explore the intersection of information security and video games, because one of my hobbies and passions in life is game development. And so I like to just basically, you know, hack out any half thought through, idea that I have for a game just on a whim, just so I have lots of dead prototypes, right? And I actually do have a couple of projects, one main project that I've managed to focus on pretty seriously on the side as of late, that's in closed alpha. Um, and other than that, some of my interests are, of course, hacking things, right? With permission, of course. Playing video games. I've been playing way too much Monster Hunter Rise on this Nintendo Switch lately. And I play a good bit of Valorant, although I've kind of fallen out of that lately. And just, whatever else comes up, catches my attention. Loop Hero, of course, has gotten insanely popular in some circles recently. I played the heck out of that. And so that's just a little bit about me, right? Um, so what we're going to talk about today is, obviously, you see the title here. This is Lifting the Fog of War. We're just going to talk about and kind of introduce some of what I see as a information security professional looking into multiplayer games, and having some experience developing those and whatnot. What I see as the main security risk that can arise, and some of the most impactful, excuse me, some of the most impactful ways that developers can help to mitigate those, right? Um, and so we're just essentially going to talk about why security is important to games. We'll look at some of those, and then we'll also have a demo towards the end, where I'll go through hacking on a really janky game that I've been building that is meant to be deliberately vulnerable. All right, and we'll go to the next slide.
Your slides aren't switching. Oh, now they are.
It was very slow for some reason. So we got this cool little title card here, right? Secure Ideas, Professional Evil. Fun fact, I made this in GB Studio, which is, maybe some of you don't know. GB Studio is this free tool. It's really cool. It lets you write and build actual Game Boy ROMs that are playable. You don't have to write any code for it. It's pretty interesting. It's kind of fun. So just kind of modify the default title screen there with this little pixel art. And Professional Evil is our slogan. So yeah. And real quick, these are my dogs. I had to put them in the slideshow because I love them. That's Eugene on the left, and that is Bogey on the right. Bogey's there passed out after chewing on a bone for like an hour. And Gene is pretending to be shy and bashful, but really he is anything but that. He's very rambunctious. All right. So this is the overworld map. I would have liked to have made a cool little pixel art, image of like an overworld, like Super Mario Overworld, or just any like, old school RPG overworld. But I didn't. But there is some pixel art to come. So what we're going to focus on is specifically, we're going to focus on real-time server authoritative multiplayer games. So not, peer-to-peer, or not, where one player is also the host. We're talking about, games that are really meant to potentially be competitive even, right? So you think like Valorant, Counter-Strike, League of Legends, or Dota, Dota 2, things like that, where, the impact of cheating and other types of exploits could really be harmful much more harmful to the game and the overall reputation and experience of players, especially with the competitive aspect. So, like I said, we'll have a high-level overview of the primary risks I think are presented to game developers when publishing a multiplayer game. We're also going to have a high-level look at some high-impact security controls, and then we'll have the hacking demo, which I already explained. So before I move on, why is security important, especially within the context of multiplayer games? So why should you care, especially if some of you are joining and you're maybe hobbyists or indie game developers? You don't necessarily work for a big studio or something like that. You might think, well, really only like these bigger publishers need to worry. But from my perspective, it's kind of the same as developing a web application in a way, right? A video game is an application, so a lot of the same security concepts at a higher level apply. A lot of the same application security concepts apply, but the technical details start to get a little different. But it's important because anytime you put something out there and you start to deal with user data and you network it and you have, it's sending packets over the internet and whatnot, there's a responsibility and there's some risk that comes with that to protect your player base. And especially for a smaller developer, if your game is, hacked to the point where nobody wants to play it anymore or enjoy it, or you've developed a game, you've started a company, and your business model really depends on the competitive nature of the game and that integrity, and people not being able to maybe, cheat their way into having all the cosmetic items or whatever it is that you're trying to sell. As much as people don't like microtransactions, they are a very lucrative, model. Otherwise, so many games wouldn't have them. So that's why this is important, not just to big companies who have huge budgets to produce their game and can maybe even afford to tank some of the hit. It also impacts smaller developers. And a simple, really quick, just case study is right. I'm sure everybody on this call or this webinar is probably familiar to some degree with Among Us, right? It's insanely popular. It's been around for a little while. It's largely developed by a pretty small team, but it's had rampant hacking, right? And to the point where the developers have had to make tough decisions. And those incidents and those cheating incidents and things of that nature, they have far-reaching consequences, not just to the players who have a bad experience, but they also cost money and time for the developers. They have to think about how to remediate these issues, how to deal with it, what to say, what is the press statement going to be? And all of that costs time, money, and energy that could otherwise be spent on, making another game or making the game better, in terms of gameplay. So that's why it's important to get these ideas and be thinking, get these things correct and be thinking of this stuff from the start when choosing to build a multiplayer game. So what happened with Among Us is a lot of the hacking was so bad to the point where they had to, as far as I was reading, right, is you search through articles and interviews from the developers and you try to piece together a picture after the fact. But as far as I could tell, they had to, the developers were at one point planning, and they may still be planning on making a sequel to the game, Among Us 2, which I think may have been canceled in favor of just making Among Us better. But they had to make that decision, and it was in large part influenced by a lot of the issues that were happening with hacking and cheating in Among Us. So that's just one example, right, sort of anecdotally of how this can impact even potentially smaller teams, even though Among Us is raking in the money because it's insanely popular. But that's kind of the goal, right? Like everybody who is an indie developer wants to maybe hit that, that gem and have it explode. Okay, so let's dive straight into talking about some of the more technical concepts here. This is just a little diagram that I doodled, right? And it's a simplification, right? Because especially when you start adding networks to things, to computers, everything gets way more complicated. But just real quick to kind of give an overview of what I mean when I say client server game architecture is I specifically mean you have here a game client, right? This cute little computer. It could be a console. It could be, whatever, a mobile phone even, right? It sends its input data to the game server over the internet, right? Mostly. But specifically what it is it's just a game server somewhere that is not a player itself, right? It is a dedicated server that is there solely to simulate the game. and then send updated game state back to the clients, right? So it processes those inputs and then it sends the updated game state. And if this is done well, this really is a powerful, I hesitate to call it a security control because it's really an architecture, but this highlights the fact that security is something that you need to get right from the start. Because trying to architect your game to be server authoritative after you've already built it and built all the networking and everything is much more difficult than saying, okay, from the start, how can I make this server authoritative? Or how can I make it as secure as possible? So while yes, there's other architectures, obviously network architectures of these games, we're not going to cover them really. I'm going to show one and just to give a comparison, but we just don't have enough time to go into all of that. But so yeah, that's a really simple, image of how this works, right? To say to the server, hey, I want to move left. Game server says, you can move left. Oh, I want to move forwards. Game server simulates that, moves your representation of your character on the server forwards, but maybe there's a wall there. So the server sends back, the positional data of where you are, and your client, utilizes that. And there's a lot more like intricate stuff there, like client-side prediction and entity interpolation and things like that. But we won't really get too deep in the weeds with that unless we have a little extra time, maybe. So, right, just to recap that, right? The server, of course, has authority over the player's actions and data. That is the source of truth in a well-designed system. Game clients are designed to be as thin as possible. And what I mean by that is, ideally in this kind of architecture, your game client that runs on your players' computers or their consoles or their phones is as trim as possible. There's not as like essentially the whole game is not simulated on that device. The actual game logic and everything like that takes place on the server, and the client really acts as much as possible as an input layer and a representation layer. So it displays the graphics, takes input and sends it off to the server. And ideally, all client inputs are validated on the server. You want to check that they're the correct data type, right? There's certain kinds of flaws that can arise from improperly handling data validation, and we'll talk a little bit about that in some coming slides. And ideally, also in a good architecture, all client inputs are authenticated and authorized on the server. And this kind of falls in with input validation, but it's not so much taking and checking the data type or the structure of the inputs or what have you. It's checking to say, hey, is this client really who they say they are, right? So you check something like a token, right, that was issued to the client when they logged into the game initially, and is sent along with each request. And are they authorized to do the thing they're trying to do? So are they who they say they are? And then if they are who they say they are, is that particular person authorized to do the thing, right, that they're trying to do? And that could be maybe your game has server commands, right? So if I'm not a server admin and I try to start sending server commands with proper authorization, to check my token and say, hey, okay, you are actually a player who is allowed to be on the server, but checking the authorization for this, you're not allowed to issue server commands because you're not an admin. Your account doesn't have that. And then so again, the server sends back authoritative player information to each connected client. And that means that it sends out a representation of each player to each client. So that's how you replicate them across the network. And then with games in general, and particularly real time, I should really say fast paced because it's not real time. You always have network latency to deal with. And that's actually one way of dealing with that is what I mentioned earlier is the client side prediction, which is a really clever way of dealing with that. But typically, these types of games use UDP with TCP-like features built onto the application layer. Now, just real quick, I'm not going to get too deep into what UDP and TCP is, but essentially UDP is a connectionless protocol. So you don't have to establish this handshake or really know that somebody's receiving the packets before you can send them. You just blast them out there and maybe they got it, maybe they didn't, right? That's a really gross simplification of that. But so TCP has a lot of features built into the protocol specification and its implementations that do things like make sure packets arrive in order, make sure they arrive reliably, right? So it'll resend packets that get dropped. Um, it has congestion control. Like there's all kinds of stuff that I don't even know about because TCP is, well, I'm actually looking at it over here that I have a huge book that's about this thick, um, just on TCP, right? And I think there's a little bit about UDP in there. But so a lot of games will use UDP and then they'll implement their own TCP like features into the application. So things that maybe are useful um, without having to use the entirety of TCP because UDP is actually more performant again because you don't have to, for example, you don't care about checking if they got the packet necessarily. So with TCP, when you send a packet, the receiver has to acknowledge that it got that packet. So there's this back and forth, right? So the volume of traffic increases. Okay, so this is another type of game architecture that's kind of common, right? And then this is a peer-to-peer game architecture. It may be called other things. You may have heard it as other things. I'm not sure. I've always heard of and called it peer-to-peer. And this is just where each game client synchronizes data with every other game client. And so in this architecture, each client is responsible for their own data. Uh, they have authority over themselves effectively. So in this example here, you would say like this game client up here at the top would maybe tell the game client down at the bottom right, hey, maybe it's a RTS or something, right? A real-time strategy game. And it would tell that game client, hey, my squadron, X squadron is here on the map, and that game client says, okay, yeah, yeah, and then in their representation, they move that game client, right, or that squadron to show the player, and so on and so forth. So as you're probably already gathering, this kind of architecture, not good for games that need to be competitive, right? It would be really difficult to implement any kind of real um, authority over data and validation of it, right? You're having to trust that that client is telling you the truth without having separate, services and systems running where maybe you can at least validate their identity, right? Um, there are ways to do it. They're all, in my opinion, very complicated. Having a dedicated authoritative server is probably the simplest way to just kind of cut out a lot of issues in terms of cheating and data validation. But even that can go wrong, right? Things can be implemented poorly and insecurely. So right, each peer has authority over its own state. Each client also has to contain the full game logic in this case, right? Because each client has to simulate the game logic. So the one client says, "Hey, I moved my unit of I'm blanking on any kind of terminology right here, but I moved one of my units, over here, and then the other clients getting that message, they then have to take that input data and then move a representation of that other player's, units to that position, so on and so forth. And there could be some level of validation built into that, but it starts to get more complex. Um, right. So each client again updates every other client of its state. So with this, there's also a high potential for cheating unless again you have complex validation logic on every client. You have logic that's saying like, oh no, you can't actually move here, or oh you're not allowed to move this fast, or you're so on and so forth. Right? It's really suitable for slower paced games such as again strategy, or not real time fast paced games such as or it's not suitable for a real-time fast-paced game such as first-person shooter. And I know I used RTS as an example. There are definitely like StarCraft that can get really fast-paced, right? Obviously at a high level. So maybe RTS was not the best example, but I think the point still gets across. And then so there's another one. There's a peer-to-peer hosted game architecture. I don't really know if that's the standard terminology. I couldn't really, you know, I've never really seen a standard, I guess, term for this, but it's essentially the same as peer-to-peer to a degree. Well, it's like a hybrid of dedicated authoritative server and peer-to-peer. And there were a lot of console games, especially on the PS3 era, like this, like several Call of Duty games use this, and a lot of games still use this today because it's actually a very cost-effective method um, of doing multiplayer. And so what this is you have a peer, a player, who is also a server, right? So each client has all of the game logic, and they have the server logic. And when a game is started, maybe there is a separate dedicated server for just coordinating the communication to get the peers connected, and to get the lobby constructed and everything. But there is one player that is chosen as the host, right? And then so their game also acts as the server, and so they're sending data to that server from their client and on locally, right? Like through inter-process communication, or just over a local host adapter, or however it ends up being implemented, right? There's a ton of ways that it could actually be implemented. And then the other clients that are not the host, right? They're sending their inputs to that host. And so this has some benefits, right? It's a little more robust than the full peer-to-peer model. It's not quite as robust in stopping a lot of cheating and other types of things as server authoritative. And it often has more latency issues depending on if whoever's chosen as the host just doesn't have a good uplink or down speed, their network sucks. But there's also a lot of power in the hands of whoever's the host, especially if it's on a PC, right? They can start to hook that process and see information that's coming into the server that their client maybe shouldn't know about, and do things like wall hacks or whatever it is, or literally like lifting the fog of war. One of the types of cheats you'll see, especially for games like this, is in an RTS game, having the ability on the client to actually remove the actual fog of war from the map in some degree, right? And because that information is just sent straight to that, and it always has a persistent knowledge of where those other players are, you could potentially see where they are when you shouldn't. Right. So it's a mix, like I said, it's a mix of server and peer-to-peer. And again, one peer is designated as a host and runs the server, as well as being a client. Client send packets to the host, and then that host also sends back the updated state to each client. And again, so each client has to contain the server logic in addition to the client logic. And again, there's a high potential for cheating when the player is the host. Even to take the PS3 example again, with like some of the older Call of Duty games. Some of you might know of lag switches, right? You could physically implement a switch onto the, basically you could tap the Ethernet cable in that you're running, right? This is one way to do it. This is the way I saw it done back when I was playing PS3 games. Maybe dating myself a little bit here. And you could actually just like flip a physical switch to like, basically cut the connection for just a moment to gain a competitive advantage because of the lag, right? And because of things like client-side prediction causing rubber banding, and so it maybe looks like to the other players you're somewhere where really you're not, and you haven't moved there yet, or you've already moved and they haven't gotten the information that you've moved yet, so they're shooting at you in the past. There's a lot of complicated ways to start to try to deal with that stuff, but most of it does revolve around having an authoritative server. As far as I've seen, right? I mean, this is a big can of worms, right, so to speak. Okay, so let's just talk about some of the high-level risks that can arise, right? Obviously, a big one is just cheating, right? If you have a game and it's meant to be competitive and you want all of your players to have a good experience, so that they feel like they have a chance when they play. They just want to play the game, they want to compete, they want to actually test their skill. And that is one of the things that your game hinges upon. For example, Valorant, Riot Games, notoriously lately has put forth a tremendous amount of effort towards securing their game. With Valorant having Vanguard, which is kind of a controversial anti-cheat to a lot of people, because it runs, right, it's a kernel level driver, so it runs with high system privileges. It makes it very difficult to actually run any kind of cheat software that it doesn't like or it picks up on. And there have been even before they did that, there have been kernel level anti-cheat systems. But this one has been very notable as of late, um, and notoriously difficult from what I hear to bypass, right? And uses a pretty aggressive hardware, ID banning, so it bans your actual machine and things like that. And of course, there are likely ways around that, and there are some known ways around those sort of things. But preventing cheating is really just a matter of um, putting, complex hurdles in place of people who want to cheat, um, or run cheats, right? Or develop cheats to make it as difficult as possible to do any of those things, because if you have, if I'm attacking a game that you've developed, I'm pen testing it or something, and I have the client running on my service, on my system, sure, it might enforce an anti-cheat system to also be running, but I still have that code. I have that process, right? It's there for me to just figure out how to pick apart. It is very difficult to put barriers in the way of that. And it's an arms race, right, between anti-cheat developers and um, cheat developers. So, yeah. And we're not going to get like really deep into anti-cheat, obviously. That is also a huge can of worms. And I'm not an expert on anti-cheat. Um, uh, but it's super interesting. And it has a lot of parallels with endpoint protection if you are familiar in like the IT security world, right? Uh, Antivirus and endpoint, detection software and endpoint protection software that picks up on malicious activities and malicious files being ran, and you know malicious activities like hooking system processes or hooking system functions with malicious code, or trying to run execute certain kinds of code in memory to do certain things, or accessing memory. Anti-cheat actually does a lot of the same things as essentially antivirus and enterprise level endpoint protection software, which I find interesting, right? Because obviously I'm living kind of in the game development world and also in the general IT, information security world, doing pen testing. So anyhow, rampant cheating, right? Obviously, the impacts that this can have is, you know, it really just hinders and hurts the experience of other legitimate players, right? And you're going to see a common theme across a lot of these things that I'm going to bring up. This just really damages the reputation of the game, right? It just causes it to go down. Uh, if I wanted to play, Valorant, and it didn't have such a strong, uh, set of security principles and security design and anti-cheat. And every time I tried to like join a game, I couldn't win. It was just all full of cheaters constantly, every single time. Right? I think it's demoralizing. Nobody really wants to play that except for the cheaters. So either I have to start cheating or just move on, right? And of course, being a free game that relies on, um, you know, that relies on the competitive nature. So things like competitions and stuff to actually draw in attention and revenue for the company, and it relies on things like the cosmetic purchases to make money. Um, Not less people playing your game means less money, right? And obviously, cheaters, especially if they found a way to cheat and just like steal in-game currency, or exploit the payment processing system or something. Um, Stealing cosmetics, you're not making any money, um, which is important, right? You need to make money off of your game. That maybe not the only point to making it, but it's important to be able to support yourself, especially as a smaller developer. But as a bigger company too, right? You have to get a return on investment and pay these companies have to pay people's salaries, etc. Um, right. So then there's also the concept of information theft, right? So a lot of games, multiplayer, um, you're going to start having, depending on, especially if you're processing transactions or selling any kind of digital item for real money, right? You're going to touch at some point people's actual information. Um, at a basic level, that's just their IP addresses, right? Taking it a little further, you have accounts, maybe that's maybe either username or maybe their email address, right? And then passwords, and as we know, uh, lots of people just reuse passwords, right? So you have to then start to think about, okay, how do I keep that stuff safe, right? How do I store that properly? And it could even be, depending on the size of your company or whatnot, you start to touch, potentially credit card information, and maybe you integrate a third party payment processor, but you still have that information, there's a boundary there, and that information is traveling through your systems in some degree, right? And a lot of responsibility, there's a lot of responsibility that comes with that. And so, um, again, oftentimes a multiplayer game stores some amount of personal information about its players, right? Could be a lot of those things. Generally, this is less going to be an issue with like the game logic, although that's definitely possible, and more with some of the supporting systems and the server and whatnot, that could potentially lead to compromise of that data. Um, Anything, just about anything is possible, really, right? Just because it's a game doesn't mean it's not possible to potentially execute code through the game server, some flaw in the game server, and gain a foothold to start running commands and whatnot on that server or that instance of a server, most likely today, right? It's either going to be a virtual machine in the cloud or a container in the cloud or something like that. Although, there are some larger companies that are still running their own dedicated, hardware and systems, but by and large, there's a lot of movement towards, there already has been, and there's continuing to be movement in the games industry to cloud-based systems. Even among indie developers, right, who are making smaller multiplayer games, it's so. Oh, with this also, right, compromise, depending on where you're located and where you're serving players out of and things like that, right, there's a lot of also potentially regulation around this sort of information. And depending on how you're handling the data, right, there could be fines associated with it through, like, for example, GDPR is being one of them, right? A big one that has been controversial among a lot of people for a number of years now. Right, compromise of that kind of information. It could, depending on how you've integrated the system, right, maybe you're using third party, could fall on them, right? Maybe they had a flaw and it's exploited on their systems. But if the exploit happened through, say, your game system or whatever, that onus is potentially going to fall on you. And either way, you're going to have to do a notification and tell people, hey, your information was unfortunately breached through our systems, right? And that's going to damage reputation, and that's going to potentially, stop new people from picking up the game and potentially stop existing players from playing it any longer. I like this one. Economy exploits. This is another kind of broad category that I see as being a potential, I guess, problem point. A lot of games nowadays do have some kind of economic system, right, in place, whether it's some kind of in-game currency or whatever that you can purchase more of. You can maybe earn it really slowly through the game or something like that, or and then purchase more with real money, and then use that in-game currency to buy cosmetics or whatever it is, right? Loot boxes, which I hate loot boxes. I think most people do, but they're no doubt kind of addictive, right? They're designed to be as such, but that's a soapbox type of talk for a different time. So anyhow, again, many multiplayer games feature some form of an in-game currency. A lot of them, this is their entire revenue model, essentially. Rather than selling the game, you sell things, right? And you get people invested in the game. And I think for the most part, this is okay and acceptable in terms of, again, like Valorant. Sure, the cosmetics are expensive, but ultimately they don't really impact the gameplay, which is good. And sometimes they have several, like, for example, Warframe, right? It has tons of different in-game currencies, and all of it kind of boils up to platinum. And there's third-party markets outside of the game for trading items for platinum and transferring it, and meeting up in game. And these sort of things start to spring up, even if you don't have issues with exploiting the economy in the game. But it's also, again, this adds another system that you have to think about how to protect, right? Is there a flaw in your game system somewhere, in your game logic, or one of the supporting servers that allows an attacker to say, you know, do something, exploit some kind of flaw, whatever it may be, to essentially gain more in-game currency for free, right? That's obviously bad because now there's a flaw to undermine the revenue model of the game and to start, building up perhaps, right? What happens in some games that have these flaws is they'll build up accounts that have a ton of money and a ton of items and sell them on third-party aftermarkets, essentially, right? Sell the account. And so you can't really stop that per se, but you can make it more difficult to do, right? If I can't attack a game as an attacker and just suddenly find a flaw that lets me add, the maximum amount of in-game currency to my account or something, then it becomes more difficult to actually abuse that economy to then start selling my account on an aftermarket, make it, I have to actually play the game or like farm that out or automate it in some other way, which comes the automation part. There are other types of controls to help defend against that as well. Again, uh, but it's kind of more difficult to do, right? It's getting into the terms of, again, anti-cheat type stuff. Excuse me. Right. So this is what I'm saying, right? This could be exploitations of flaws in the game logic itself. If there's maybe, think of an example. You could think of an example such as having a system where, uh, yeah, having a system in which you gain the in-game currency slowly by doing some kind of quest, but you could also buy more of it. But maybe there's a way to just say, tell the server, that you've completed this quest over and over again without actually having to complete it. So you just write a program to just start running that, sending some kind of, information that you've reverse engineered through, capturing the traffic and looking at it and whatnot. However, it's been figured out, right? And now suddenly you've been able to gain all this in-game currency, and you can just start getting, buying cosmetics or items or selling your account, etc. So there's also remote code execution as a flaw. Let me check the time. How am I on time? Okay, so I gotta speed up a little bit. Um, so there's remote code execution, RCE, or remote command execution. This just needs to be mentioned, right? This is just the presence of a flaw that would allow an attacker to execute malicious code or commands on any system involved in the game. So now, anytime you have a system that is able to talk over the network with other things, this becomes a potential concern, right? And not just for games, but this is, again, things that can impact games, and to try to get people who are thinking about making games or are otherwise involved in securing games or whatever, just to think about this stuff a little bit more. Mainly, I want to convince developers, right, to start thinking about this sort of stuff from the get-go. Where this could be against the server, it could be against other clients potentially, especially depending on the architecture. Right? If you have a peer-to-peer architecture where these clients are communicating directly with each other, you have potentially a known IP address of another player, and maybe you find a flaw in the game client or the game server that lets you do remote code execution. Well, now that's really bad. Or it could even be through mods and things like that. There have been examples of that. Where people could create maps that would, when loaded into the game, would cause a buffer overflow and then could do, code execution that way. Right? These game systems are complex, right? So there's all kinds of little nasty ways that things could go wrong and have gone wrong. It could also be the supporting systems, such as web applications. Maybe it's the web app where you sign up for an account or something like that, or an API at a game to pull statistics or just whatever, or database servers, right? It's a lot of stuff. So, and this kind of flaw, exploitation of this flaw, is very critical because this can lead to just a takeover of the entire server, which could lead to takeover of play accounts, theft of data, or just about anything else that an attacker thinks to do on a system that they've compromised in this way. There's also denial of service, which is a risk. So kind of an aside, right? When Secure does penetration tests, unless the client explicitly wants us to test for denial of service conditions, we generally don't try to do that. We don't try to just take down that, because one way to do that is just to flood something with so much traffic that it can't handle it. And there are ways to scale that out and deal with that, but you generally need some kind of infrastructure in place, some sort of systems to handle that traffic and distribute it and whatever, and start blocking packets that it's determined are, being used to flood, the system with traffic, etc. But then there's other kinds of denial of service where there could be a flaw that just crashes a game server or crashes other game clients, right? And while generally we don't explicitly test for that, we don't try to like knock over somebody's a client's production web server or anything like that, unless they ask us to. But with games, looking for these kind of game systems, looking for these sort of things becomes more important. It's still important otherwise, but downtime in your game or your game servers results in people not playing your game, results in frustration, which again leads to people, losing faith in the game, losing interest potentially, and not wanting to pick it up. So what does all of that lead to? Well, ultimately, most of this leads to reputation of the game and of the company going down. Not to mention the responsibility, the ethical responsibility for, say, people's information and things of that nature, and potential fines that can come with that. But reputational harm is the number one driving factor um, here, right? You don't want to have to tell people that they've got breached, but if you do experience a breach, ethically you have to, and legally oftentimes, depending on what you're subject to, what kind of regulation you're subject to, etc. Uh, you have to tell them. You don't want to have to do that, right? So it's good to get this stuff right from the start as best as you can, because you don't want your reputation harmed so badly that you worked so hard to launch a game, maybe as a smaller company, and you didn't think about security from the start, and your game starts getting hacked really badly, and it just becomes this situation where nobody wants to play your game, right? And you could have, maybe you're selling the game, or maybe you wanted to do a model where it was free to play, and you sold items and things like that. Well, now you've got a problem, right? You're hurting your ability to make money and potentially make more games and to pay your employees and just whatever the scale is, right? This is bad. All right. So we're going to move on real quick. I'm going to breeze through some of this next stuff too, because we're going to look at it when I do a demonstration. Also, this little pixel art I made here, I put this little animation together in GB Studio as well. Now that I think about it, like some of the next images should have been flipped a little bit, but it doesn't matter. Okay, so we're gonna look at what are some of the things you can do to try to mitigate this sort of stuff. Now you'll notice anti-cheat's not there. You can do that, and there are pre-packaged anti-cheat systems. Punkbuster, Easy Anti-Cheat, Valve Anti-Cheat is a big one, right? Those are big ones that a lot of people are probably familiar with. And if you're going to put a game out through Steam, for example, you're essentially going to get like Valve Anti-Cheat built in for free. Although I'm sure I'm sure you have to do some programming in the API and whatnot, but that is there for your use. But so in my opinion, the top things that can be done that have the highest impact on protecting yourself and your players and your reputation when putting out a multiplayer game, specifically like a first-person shooter or something that's fast-paced, right? Is to architect it to have server-side authority, right, and a dedicated server, to utilize encryption on traffic, to implement authentication and authorization on actions and basically anything that a player can do, and to validate input. So we're going to choose server authority, and we're going to throw it at the game here. Right? So what is server-side authority, right? I've said this a couple of times already, but the server has the final say over the player state. Clients typically only send commands or inputs, right? This actually increases the difficulty of client-side hacking, right? If there's not that much that the client does or really knows about, or tells the server about its own state, like there's not that much that you can do to implement hacks on the client side. For example, if the server never trusts, for example, movement speed from a client, then there's really not any way that I can tell the server to move me at a higher speed, right? I could hack my client to say that my movement speed is 200 times what it should be, and on my end, I'll probably move around way faster. Until the server sends back saying, hey, no, this, you're not over there, you're actually over here, right? And my character will snap back, right, or whatever, depending on how that's implemented, if it has entity interpolation and client-side prediction and all that good stuff. So, and again, the server is responsible for sending updated state information to each client about themselves and the other players. And this is usually a standalone hosted server. But again, as we saw earlier, there's that combination of standalone and peer-to-peer, where there's still technically you can have server authority, but that server is also running on somebody's machine and that is a player and has incentive to potentially cheat. And now they have they have the server, right? They can potentially do a lot of nasty stuff there, or fun stuff. It just depends on what your goals are as a developer, right? And then there's encryption, right? Um, so encryption, right? Basically, communication between the client and server is encrypted. That means that using strong encryption, like usually a TLS, something symmetric, like TLS using maybe AES to do the symmetric, um, to establish a symmetric, communication channel. Um, but what this does is this prevents most man-in-the-middle attacks, right? And this also makes it more difficult to reverse engineer and attack the game network protocol, which is one way that a hacker or a cheater can try to do things, right? Is to actually look at the packets and then try to manipulate them. Um, that's generally actually the more difficult approach. The easier approach is to try to reverse engineer the game client, right, and see what functions it's calling, maybe modify the code to run a modified binary, or if you can't do that, try to hook system calls that it makes with DLL injections or any dynamically linked libraries that you can, as an attacker, you can write a cheat to try to hook those and intercept that information, or hook the code that does the encryption and read and modify the data that is sent before it becomes encrypted by the game client. Even extracting the certificate from the game client is something that can possibly be done, and then used in packet sniffing software or just custom packet manipulation software that is written to decrypt the packets and then re-encrypt them. This also prevents types of traffic sniffing on based cheats on land-based games. So like if you are, even a competitive game, you think a big competition for a game, right? Maybe where everybody's on the same network or something like that, right? And maybe if they're on the same network or all the devices are on the same network, technically they could see each other's packets, right? There are ways to try to sniff that. Again, it depends on the network architecture, but there are ways to try to like capture and view that traffic. And if it's unencrypted, then there's a potential to gain competitive advantages that way, right? This is actually another big incentive, right? Any games that have competitions that pay out money, there's a lot of incentive to cheat, right? And to try to cheat because there's money on the line. There's money to be made. There's money to be made making cheats and selling cheats, right? And all of that comes at harm to the people making the games and the other players who, obviously have to deal with that and have a bad experience. It also provides confidentiality and integrity for communicated data, right? In the same way, you shouldn't have a web application that sends like username and password over HTTP. It should use HTTPS or to have an encrypted channel. The same thing applies at any level, depending on what the data you're sending. So maybe you're not using HTTP traffic, but you're using low-level UDP packets. Well, the data in there should still be encrypted, especially if it contains sensitive information like usernames, IP addresses, or authentication tokens, or whatever it is you end up putting in there, right? There's so many possibilities, it's hard to encompass them all. So then there's authentication and authorization. Now, this provides proof of client identity, right? This is like a token that says, hey, I'm Corey, and then the server can verify that token and say, yep, this matches up. The signature is valid. I'm able to validate that this was generated by whatever certificate or key I trust. And this allows the server to determine if a client is allowed to perform a specific action as well. That's the authorization part. Authentication is proving who you are. And authorization is determining what you're allowed to do and whether you're allowed to do it. So this can actually also help mitigate potential attacks, which allow players to spoof actions as other players, right? So with good authentication, maybe I can change what I say my username is in a packet or something, but I don't have somebody else's token, right? So I still send my token along and I have my username, right? Well, the server goes, hey, this token doesn't match with this username, so I'm not going to let you do this, right? But if that check isn't there or isn't done correctly, then there's potential for me to say that I am another player and start doing things as them. And this can also be tied to accounts, right? for safeguarding of items, currency, etc. This is the same kind of authorization thing, right? You want to be able to tie the information to a player so that when they say who they are, you can trust that. Also, I think my camera is about to die, unfortunately. So if it goes out, oh well. And then there's input validation. Okay, so input validation is also very important. And basically, this just checks if the data sent by a client is valid for the action being performed. Is it the right data type? Is this an integer, right? Not a string. Is this trying to write into a buffer, right? Is it trying to send data that's too big for a buffer if you're using a memory unsafe language, right? So doing proper input validation in languages like C or C++ can actually help prevent memory exploits. It can also help prevent some classes of remote code execution. Again, those memory exploits technically could be remote code execution, but what I mean here is an insecure deserialization. So a lot of game objects will serialize or a lot of game engines will serialize an object in some way, which means to just pack it into some kind of format to be sent over the network. Well, a lot of languages like C# and Java and even like Godot game engine, for example, they have the ability for like Godot has the ability for scripts to be serialized in those objects and sent over. C# and Java, it's possible to insecurely deserialize an object such that the attacker can control what type it becomes once it's deserialized, which can then allow them to craft, an object or a packet that loads some other code on the system that they've sent it to and does what they want, executes some commands or whatever.
Hey, Corey, just letting you know, you only got about 3 minutes.
Yeah, we'll probably end up going just a few minutes over, but so you feel free to stick around for that or not, because we're right at the demo. Okay, so I've got this kind of goofy little diagram here, and what we're going to go through is we're going to look at I'm going to take a game client and I'm going to run it through this attack proxy that I wrote. So rather than reverse engineering the game client, which probably would have been the easier approach here, I actually went about it by writing a program that intercepts the communications from one client to another and starts to manipulate those packets and takes advantage of a flaw in the game server logic to pretend to be another player. And this leverages the fact that the game server, when it initializes all the other player information to each client, it has their client ID, right? So this actually highlights a lot of flaws that I just talked about, and a lot of security controls that are missing from this particular thing. And so what will happen is we'll send a disconnect packet, which in the case of my demo will disconnect the other player, but unfortunately it's also going to crash the game server. I have to fix that. This is using an open source project I've been building that is really in its infancy. And I'll talk more about that in just a few moments. But let's just jump into that real quick. Oops. Let me close that. I didn't realize that was still open. Alrighty. So let's make the text a little bigger here. I hope that is big enough for you all to see clearly. All right. So I have got a instance of Wireshark open, and I'm going to start a new capture as well. And we can make this bigger too, I believe. We should be able to. It might not show, well, obviously we need some packets, and this is capturing packets right now, but I've got a filter applied so that it's not just showing all the random localhost stuff that's running on my system. So what we're going to do really quickly is I've got this project, this DVFPS, which stands for Damn Vulnerable First Person Shooter, and this is open source. But again, it's in its infancy, so it's very messy, and I need to rewrite basically all of it. But we're going to take this and we're going to run, rather than running a standalone binary as a server, I'm going to run the server through the game engine editor real quick, just to have the output right here in a nice way. So right, we get a little bit of information here, just showing us. Oh, this lets me zoom in. just showing us a little bit about that it started, right? It's okay. It's listening on this port 9999. It's hello from the server. It's not showing anything because it doesn't do anything. And then what we're going to do is we're actually going to run this attack proxy that I wrote in Golang over here. We won't go through all the source code, but it's kind of a messy series of byte level manipulations of UDP packets. But essentially what it does is I will connect my client to this proxy, and then we'll run the other client connected directly to the server to simulate us being on separate networks, right? And connected only through that server. And so what this does is that gets the connection, it establishes that connection, and then it is going to read these packets as they're going through. And then when it sees a specific packet, specifically this disconnect client packet, it's going to start an attack on that. So it's going to extract the other client IDs when the server initializes the player instances in my client from the other player. It's going to extract that ID, and then it's going to attack it when I issue a disconnect packet. And for the sake of demonstration, I essentially implemented this kind of heavy-handed function here that handles the messages, right, from the clients on the server, right? So this just handles these state messages, pulls out a message type from the message, and then here's, it processes the input movement. So I only send, key presses, so I can't tell the server that I'm moving, 100 times what I should, but I can tell it that I want to move left or right or whatever, and then it simulates that movement, and we'll see that in just in a moment. Reads the mouse motion, so it knows where to aim its representations of the players. And then I added this disconnect client just because, just for example's sake. And this message basically deletes a representation of a player from the server. And that's actually going to cause the server to crash because I don't have the logic to cleanly do that just yet. That'll happen in the rewrite. But there's actually a kind of subtle flaw here, right? These messages contain like a client ID in them. But me as an amazing programmer, I made a mistake and I accidentally do this check against itself. So this check's always going to return true. So because I know the client ID of other players, I can send a packet and I can then embed into that packet the ID of another player, and the server is going to accept that and it's going to disconnect them. But as you'll see, it's actually just going to cause everything to come crashing down. But we'll see how the output message that it does disconnect the other player. So we'll start our attack proxy, and it's just going to listen on this port leet 1337, and it's going to proxy traffic to localhost port 9999. Yeah. And then so over here, hopefully you guys can see this. It's coming through clearly. Maybe we can make it a little bit bigger. So I'm going to run an instance of the game as a client. I'm going to tell it to use the server IP localhost 127.0.0.1 and use the port 1337. And that means that it's going to go through my proxy. And I've got the server already running. So I'll go ahead and start that up. Right, and we'll see we've got this little FPS here. It's really small. I made the windows small so I could fit everything kind of on the same screen. This is the server view. It just takes whatever the first object is that has a camera and just shows that on the server, right? It's just a way to see something. Okay, and we can see this is the client ID of what I just connected as, and we can see that my proxy has that client ID. It's aware of that, so I don't attack myself per se. And so what I'll do now is I'll start one more, and this is going to be the one where I'm going to tell it to communicate with port 999. So it's going to talk to the server directly rather than going through my proxy. And as soon as we start that, we're going to see some stuff pop up here, right? And it got a bunch of packets back from the server, and we should actually see a bunch of stuff here in Wireshark as well that we can take a little bit closer of a look at. So we should see, I'm looking for packets that say create player, and this is what the server sends this message back to to invoke a function called create player, and that instantiates those player puppets And this has a bunch of information in it, but importantly, it may be kind of hard to see. Unfortunately, Wireshark's not the most visually friendly tool. But you have this client ID here encoded, and then we have some information that tells us what kind of value that is, this 02 here, these 4 bytes, 02, and then 000. That actually just tells us that it's an integer. Makes sense, which I know that, I wrote the game. And then we can read the next 4 bytes after that, this 2AFE4665. We could read that, convert it from little Indian type of little Indianness formatting. It's just the order of the bytes. And we can convert that, and then we can convert it to an integer. And that will give us this client ID. I don't know off the top of my head. Obviously, I didn't do the conversion in my head. I don't know if this particular client ID matches with, this client ID. But that's what we'll do. We're essentially going to be in our attack proxy. It's going to be looking at these bytes, and it's going to do just that. It's going to look for this marker, then it's going to extract this information, which is what it did. Then when as the attacker, I think it was this one, yeah. As the attacker, when I send, let me match up this is the attacker, yeah. So let me make sure I move this down to here, and then pull up the server and just kind of move that there. So yeah, so I've got the client ID showing in the window title, and it's my attacker client ID is 169915140 right? It doesn't really matter that much, but also I haven't implemented full gameplay yet, so obviously I can't shoot this other player. But we can see this is synchronizing across the network, and it's synchronizing my movements down there on the lower left, right, to the other clients as well. It might get a little laggy because again, I'm like streaming all of this stuff, running this proxy, and like running the game too, all on the same localhost adapter. So it might get a little messy. But I've got this really simple pause menu, right? That just has this disconnect command. And you can see it's going to actually disconnect my client because of the client side logic of this button, but it will send a packet that tells the server to disconnect the other player. And what you'll see is after a moment, it's going to lose its connection. And we can see here, it might be really a little hard to see. And I think it is. But it actually disconnected the client. And you'll see in my attack proxy, right? It's attacking client. It's not attacking us, it's attacking the other one. So it issued this packet and okay, there we go. See, we've disconnected from the server. And so we were able to successfully, I know it seems a little uneventful, right? But we were able to essentially capture that traffic, modify the ID within it, and actually right here, which I don't know if any of you are really familiar with Go, but basically that's what we do. We disconnect the other players, right? We loop over the IDs that we've discovered, and we go to the starting byte of that ID, and then we copy the ID that we're looping over into the buffer we just read from my attack client, and then we write it back out to the server, and the server happily processes it, and that's why this is not disconnected, right? It disconnected the other player from the game. Now, I still have to obviously implement some logic to not disconnect my attack client when I run that button or when I push that button. But yeah, so sorry, that was a lot of stuff, right? It's hard to cram that into an hour. Game security and game hacking is very, very deep. There's a lot of stuff, right? Obviously, like I've so many different topics that could be touched on. Server side security, network security, packet analysis right here, and like with Wireshark, we can look at these. Well, maybe not. I think it's going to freeze. And Wireshark has frozen. Never mind. I was going to show you the. Oh no, there it goes. Okay, so we can actually see the messages that came through once it filters all these packets. I should probably stop it from capturing now. Cancel. We can actually see, right? It sort of spammed out this message a couple of times from my proxy, but we can see kind of some of the strings that get interpreted here, right? This handle message, it's got an ID. The message type is disconnect client. And what the proxy did is over here again, we have this ID, we have the identifier, and then this actual ID is the ID we injected into there of the other player. So yeah, again, that's a lot of stuff to try to cram into I'll go back to my slideshow. Yeah. That's a lot of stuff to try to cram into 1 hour. But I hope what it has done is kind of inspired you to think about this sort of stuff some more. If you're developing a game or you're interested in games or you're just interested in security and whatnot, you think about how security impacts video game development as well.
Hey, Corey,
Yeah.
if you look in the chat, you have 2 questions. If the game offers an offline or bot mode, does the game logic have to be on the client side?
Hold on. Oop. The chat box is spazzing out a little bit for me. Okay, so if the yeah, I'm sorry, I'm scrolling back through some of the questions now too. There's the Among Us, yeah, about the Among Us thing, and then there's let me see, let me make sure. I just want to make sure I get to all of these actually.
Yeah, there's 2 main questions.
Yep. Okay. And then, so if the game offers an offline mode, offline or bot mode, does the game logic have to be on the client side? So do you mean like, okay, for example, like in Counter-Strike, if you play like CS:GO, for example, if you play against bots, I'm gonna assume that's maybe what you mean. It just depends on how it's architected. You could, in theory, have none of that logic in the client and it still connects to a server, and that would be like an online bot mode. But for an offline bot mode, yeah, it would most likely need some of the game logic. It would need the logic to process, matches and things like that, right? So, for example, one of the reasons why you can actually host like a Counter-Strike, like a CS:GO match on your own machine is because it has that logic, right? But Valorant, you can't actually do that. So when you host like a private game in Valorant or something, you're actually hosting something on one of their servers. Um, so yeah, it would still have to most likely for an offline bot mode, you'd have to have most of that logic present in the client. Now, whether or not that lets you host a server or how it actually does it, because it could be done by having the game host a server locally on your system and then communicating with it. Or it could just run it all within the client kind of without a server. There's a lot of ways to develop it, right? And none of them are necessarily right or wrong. I hope that actually helped. And then did I miss another one?
It's the being an application cloud security engineer question.
There we go. Yep. Being an application cloud security engineer, how different is the game security domain? Do general AppSec/cloud security skills translate well, or are there some specific skills someone needs to learn to transition into the game security world? That's a really good question. So what I didn't mention at the start is one of my areas of expertise is actually cloud native technology. Specifically, I'm very invested in Kubernetes security. And there's a lot of games, and there's even I'm forgetting the name of it now, but there's a project to abstract you running game servers on Kubernetes. And there's also cloud platforms. There's offerings by a lot of the major cloud providers to host and run your game servers. And so from that aspect of it, a lot of the application security and cloud security practices will apply, right? Because if you're running something in the cloud and a game is an application, right? It's just maybe has a few more moving pieces than you might expect, or the minute technical details are going to be different, right? But a lot of that stuff still applies, and no matter what, the basics of security and application security are going to apply, right? You need to have authentication and authorization. You need to encrypt sensitive data. You need to make sure you're encrypting data at rest securely, right? And things like that. What comes down to it, and this is why I find it interesting, because at first, when I first started approaching game security, it really seemed like this mysterious thing. But basically, all of the stuff I already knew from security in other domains really translated. The hard part was the specifics of stuff, right? So, obviously for this demo, I had to dig in and analyze the protocol that my game was using. and figure out where these specific bytes were and read them, or I could have reverse engineered the game client and modified it and things like that. But even that is close to some of the stuff you might do with other types of application security. So yes, the principles of cloud security and application security absolutely apply, especially if your game is utilizing cloud services.
We hope you guys enjoyed it. We will post this after we clean up the recording to our YouTube channel. Please check us out, and we hope we see you guys the next webcast. And don't forget, tell your friends because it's free.